Excuse me. All right. So just a quick couple of announcements. The schedule for today and for tomorrow, a little bit adjusted, a little bit different than what we're used to. 9:25, obviously this hour just started. We'll be done at 10:15. And then you go to seventh hour. So make sure you go to seventh hour after this hour. And then fifth hour is after seventh. I know it seems weird, but for those who are in person, they need the opportunity for lunch. And rather than redoing lunch schedules, we just flip-flopped fifth and seventh hours. Tomorrow, 8:30 starts second hour, 9:25 fourth hour, 10:20 sixth hour, and then again 11:15 back to fifth hour due to lunch. Questions about the schedule? All right. Moving on. Today we're actually going to do a little bit of review of factoring. So if you remember factoring from last trimester, that will be great. If you don't remember factoring from last trimester, well, that's why we're going to do this review. And then next week we'll use factoring in solving quadratic equations. So if you have the chapter 9 packet, the yellow packet, we are starting on page 7. The biggest key is always check for greatest common factor before you try any of these factoring methods. So if the coefficient in front of the x squared is 1, we use that x method where we looked for two numbers that multiply to negative 16 and add to negative 6. And so because they multiply to a negative, we know we have to have a positive and a negative value. And they have to add to a negative number, so the negative has to be the larger of the two factors. If we don't know where to start, 1 and the number is a good place to begin. And then add those together, they don't add to negative 6. And then try 2. 2 and negative 8. Well, 2 plus negative 8 is negative 6. So that is the factor pair that we would use. And our answer x plus 2, x minus 8. All right. If there is a number other than 1 as our coefficient, then we use the slide method. And remember the slide method, we take that number, slide it all the way over, and multiply. So this we would rewrite x squared plus 7x. Negative 6 times 5 is negative 30. Now we don't have a number in front of the x squared. We can continue with the x method. Two numbers that multiply to negative 30 and add to positive 7. So again, multiply to a negative, so we have to have a positive value and a negative value. Add to a positive, so the larger factor has to be our positive factor. Negative 1 and 30, again, doesn't quite add to 7. Negative 2 and 15, not quite. Negative 3 and 10, that one works. So x minus 3, x plus 10, but we're not done. When we use the slide method, to get these factors, we multiplied by 5. So to get our answer, we're going to divide by 5. All right. Is there a number first of all, is 3 divided by 5 an integer? No. Can it reduce? Can that fraction reduce? Is there a number other than 1 that evenly divides into 3 and 5? No. So that's reduced. So what we do is we take the denominator and put that as the coefficient of x. So this is going to be 5x minus 3. Check with the second factor. 10 divided by 5 is 2. Because that comes out even, we just have x plus 2 as our other factor. And this is our answer. So don't forget that division part. That's kind of the key. All right. We're going to do about 4 or 5 examples, and then I'll let you guys try 1 or 2, and then that's going to be class. All right, a couple of special cases. If we have an equation in the form a squared minus b squared, that's called a difference of 2 squares. The first term and the last term are both perfect squares, and there's a minus sign in the middle. That's the key. To factor that, we would get a plus b and a minus b. And again, the order doesn't matter. For example, 4x squared minus 49, perfect square, perfect square. The number that we square to get 4, or the number that multiplies by itself to get 4, is 2. So we get 2x plus the number multiplied by itself that gives us 49 is 7. And 2x minus 7. So if you can memorize that form, it makes things easier. A second special case is when we have a quadratic in the form a squared plus 2ab plus b squared, and that's a perfect square trinomial. And it factors, in this case, into a plus b squared. The great thing is you don't have to recognize that you have a perfect square trinomial. You can factor using the X method or the slide method, and you will get the exact same answer. If you do factor using the X or the slide method, if there's a number in front of that A, both factors are going to be exactly the same. And you can write it just like that, a plus b, the quantity squared. So in the case of this example, 16 is 4 squared, 8 is 2 times 4. It is in that perfect square trinomial form. And we have our perfect square trinomial. All right. Remember to check for a GCF first. If you leave a greatest common factor in the problem, one, you're going to have some messy numbers to work with, and two, your answer is not going to be correct. The factoring methods don't work if we have a common factor that isn't factored out first. So in this case, I always look first at the x squared. If there isn't a number there, I don't worry about a greatest common factor. Although there could be a variable as a greatest common factor. So in this case, if I use the x method, two numbers that multiply to negative 42 and add to positive 1. I'm amazed at how many students think, oh, 42 and 1, but negative 42 plus 1 is not positive 1, okay? You can start with that one. Again, the larger factor has to be the positive one. And you could try negative 2 and 21, negative 3 and 14. 4 is not going to work. 5 is not going to work. 6 will work because 2 and 3 both work. And look at that, they add to positive 1. Example 2. Now here I have a number in front of my first term. So I'm going to check to see if 3 is a factor of the other two terms. And it turns out it is. So 3 divides evenly into 24 and 48. So I know I'm going to have a greatest common factor. It's going to be 3. And then I also notice I have an x in each of my terms. So my greatest common factor is going to be x to whatever power it is in my last term. In this case, it's x to the first power. When I factor out a greatest common factor, it's basically like I'm dividing. So 3 divided by 3 is 1. I had x cubed. I factored out one of the x's. I'm left with x squared. 24 divided by 3 is 8. I had x squared. I factored out one of the x's. I'm left with x. And 48 divided by 3 is 16. I factored out the x, so I don't have an x in that term. Again, you may recognize this from the example we did with the perfect square trinomials. This was x plus 4 squared. If you didn't recognize that, again, you can go to the x method, multiply to 16, add to 8, 1 and 6. They're both positive, so my terms or my factors have to both be positive. 1 and 16, 2 and 8, 3 won't work, 4 and 4. You could also write this as 3x, x plus 4 times x plus 4. A little more writing that way. All right. Here we don't have variables in all three terms. That's good. I do have a 2 in front. Does that evenly divide into my other coefficients? Well, 9 divided by 2 does not give me an integer value. So I don't have a greatest common factor other than 1. Because I don't have a greatest common factor, I can go right to the slide method. Take the 2, slide it across, multiply by 4. X squared plus 9x plus 8. Continue with the X method. Find 2 numbers that multiply to 8 and add to 9. 1 and 8 is a possibility, and it does add to 9. So I get x plus 1, x plus 8. But I'm not done. To get those factors, I multiplied by 2. So to get my answer, I'm going to divide by 2. 1/2 does not reduce, and 1 divided by 2 is not an integer. So that goes up as the coefficient in front of the x. Eight divided by 2 is 4. And we're done. All right, another example. 4x squared minus 28x plus 49. Again, checking for our greatest common factor. 4 divides evenly into 28, but not into 49. So 4 is not a greatest common factor. So then we could try the slide method. Take the 4 and slide it all the way across. Find 2 numbers that multiply to 196 and add to negative 28. So let's see, we can try. They have to multiply to a positive, add to a negative, so both are going to be negative. That doesn't work. How about negative 2 and negative 98? That doesn't work. 3 is not going to work because the digits do not add to a number divisible by 3. 4, and we know 4 is going to be 4 and 49 because that's what we multiplied to get 196. That doesn't work. 5 doesn't work. 6 doesn't work because 3 doesn't work. 7 works, I believe. That would be 2 and 8. Um, 8 is not going to work. 9 is not going to work. 10 won't work. 11 won't work. 12 won't work. 13, and obviously you can use your calculator to check these. I think the next one that works is 14. And 14, negative 196 divided by negative 14. It gives us negative 14 and negative 14. And that adds to negative 28. It works. So this is actually a perfect square trinomial. So we have our x minus 14 and x minus 14. But again, if you didn't recognize that, you can use the slide method. We just have to remember we're going to divide by 4. Is there a number that evenly divides into both 14 and 4? They're both even, so 2 will divide into them. So I'm going to reduce my fractions here, call this x minus 7 halves and x minus 7 halves. That doesn't reduce anymore, and when I divide, I don't get an integer, so the 2 is going to go up in front of the x in both factors. So you can see in this example, it's a little more difficult if you don't recognize that special case. And then because our factors are exactly the same, we could write it as a perfect square. Whew. All right. So again here, look for a greatest common factor, and there is one. There is an x squared in both terms. And then check 18 and 32, do they have a common factor? I think 2 is a common factor. And then the big key here, there are only 2 terms. So I want to check, are they perfect squares? Is 9 a perfect square? Yes, 9 is 3 times 3. Is 16 a perfect square? Yes, 16 is 4 times 4. So I have 2 terms, they're perfect squares, and we're subtracting. So that means I've got my difference of 2 squares form, and I can use my shortcut. Square root of 9 is 3. The x squared would give us an x. Square root of 16 is 4. All right. Let's take a look at this one. Again, looking for common factors. Well, I know for sure that these are both divisible by 2, or the 3 terms are all divisible by 2. I can't factor any further. I know 4 is a perfect square, but 15 is not, so it's not going to be a perfect square trinomial. That would have been good. That would have made it a little bit easier. I do have that number in front of the 4, so I'm going to use the slide, or the 4 in front of the x squared. I'm going to use the slide method. Four times 15 is 60. So I want to find 2 numbers that multiply to negative 60 and add to positive 4. And again, if you can find those right away, that's great. If you have trouble, they have to multiply to a negative and add to a positive. So I'm going to have a negative smaller number and a positive bigger number. Just checking all of the factors until I find 2 that add to positive 4. And negative 6 and 10 add to 4, so we're good there. Negative 6, 10. Don't forget that common factor. And then divide by 4. In this case, this first fraction reduces. There's a common factor of 2 that I can factor out. The second term, the second factor, there's also a common factor of 2 that factors out. Because I'm left with a fraction, the denominator goes up as the coefficient of x. And there's our answer. Excuse me, there's our answer. All right, couple for you to try. And I'm going to just give you I'll give you 3 minutes to go ahead and try these, and then we can take a look at answers. All right. So the big key for this first one, we only have 2 terms. So I want to check, are they perfect? Well, first of all, I'm going to check for greatest common divisor, greatest common factor. 9 and 100 do not have a greatest common factor. 9, the only factors of 9 are 1, 3, and 9. And 10 is not evenly divisible by 3 or 9. And we never call 1 a greatest common factor. So it's 2 terms with subtraction. So that seems that it's going to set up as a difference of 2 squares. 9 is a perfect square. It's 3 times 3. 10 is a perfect, 100 is a perfect square. It's 10 times 10. So that gives me that answer. Number 2, again, looking for a greatest common factor. Well, the problem here is 7 and 5 are both prime numbers. They're only divisible by 1 and themselves. So we don't have a greatest common factor. So then the next option, use the slide method because we have a number in front of the x. Multiply by 6, we get x squared minus 7x minus 30. I'm going to do I'm going to move this. That's what I'm going to do. Two numbers that multiply to negative 30 and add to negative 7. So they have to be opposite signs. The negative number has to be the larger factor. So 1 and negative 30. That doesn't add to negative 7. 2 and negative 15. That doesn't add to negative 7. 3 and negative 10. That does add to negative 7. So I get x plus 3, x minus 10. To get those, again, I had to multiply by 6. So now I'm going to divide by 6 and reduce if I can. 3 over 6, oh, those both have a factor of 3. So they reduce to 1/2. 10 over 6 has a common factor of 2, so that would be 5 over 3. Because our factors are fractions, the denominator goes in front of the x as the coefficient. All right, questions? Due to our limited time today, our shortened class period, I am not going to meet with you individually. I'm going to put the schedule back up, though. Seems like some didn't know the different schedule for today. There is the schedule for the hours for today and tomorrow. So you've got about 15 minutes or so to work on your note check or your homework. Homework is posted and is accepting submissions. So pretty short note check, maybe try to get that done. And then also remember, any makeup work from chapter 8 is due by Wednesday next week. I've gone through the stuff from 8.1 to 8.3. It's past time. So you can work on anything 8.4 through 8.6 that's missing, and still turn it in for credit. And then also, try to keep up on chapter 9 work.